Hello everyone, myself Yash Kumar Yadav from KNIT Sultanpur,
and myself Vikas Singhwar from KNIT Sultanpur.
and we have made a project on IoT based home automation system on Emertxe IoT internship. We are here to present our PPT.
So let us have an overview. So the contents of our project is overview, Internet of Things, C programming, embedded systems, Pixim Lab, Arduino IDE, Blink app, peripherals, project requirements, and project integration.
Moving ahead with the overview. In this project, we are building an IoT based home automation solution. The home automation is simulated on the Pixim Lab simulator. Blink IoT mobile application is used to control the devices, and the project will be able to control the garden lights, temperature of the home, and the inflow and outflow of water in the water tank.
So basically this project is based on Internet of Things. So what the Internet of Things is a system of interrelated computing devices, mechanical and digital machines, objects, animals, and people that are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to human computer interaction. Let us see an example. Essentially, any device that can gather and transmit information about the physical world can participate in the IoT ecosystem. Smart home appliances, RFID tags, and industrial sensors are the few examples.
Moving ahead, we have taught in this internship program about C programming. C programming is a powerful general purpose programming language. It can be used to develop software like operating system, databases, compilers, and so on. So basically, in this internship of 1 month, the topics which were covered by sir were introduction to C, data types, operators, arrays, pointers, function, recursion, strings, storage class, preprocessor, UDT, C++, OOPS, and constructors.
So let us have a brief introduction about the embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function of larger system. The system can be programmable or have a fixed functionality. The main components of the embedded system are microprocessor, microcontroller, SoC, memories, EEPROM, flash memories, and the tools of embedded system are Arduino IDE, Pixim Lab Simulator, Arduino UNO board, ATmega 320, and Null emulator.
Starting with the Pixim Lab. Pixim Lab is a real-time emulator of development board with integrated MP-LabX AV RGDB debugger. Pixim Lab supports some Pixim microcontrollers and some SIM-AVR microcontrollers. Pixim Lab have integration with MP-LabX Arduino IDE for programming the board controller. In the Pixim Lab, we will use the spare parts to integrate our project.
The Arduino IDE, the open source Arduino IDE makes it easy to write code and upload it to the board. This software can be used with any Arduino board.
Our project will be controlled by the Blink app. A Blink app is an IoT platform for iOS or Android smartphone that is used to control Arduino, Raspberry Pi, and Node MCU via the internet. This application is used to create a graphical interface or human-machine interface by compiling and providing the appropriate address on the available widgets.
The main peripherals of our project are CLCD, LDR, and the temperature system. So the CLCD is used to display the weather what are going in our project, weather temperature system, and serial tank, and many more things.
LDR will be used to represent as a light source of light, which will judge whether the environment has a good source of light or low lighting, based on which our LED will glow. If there will be if we will increase the intensity of LDR, our LED will go low down, and if we will decrease the intensity of LDR, our intensity will glow up. In the temperature system, there is a heater, cooler, and a temperature reader. Temperature reader is connected with pin AO, and it will record the temperature of the surrounding, and it will be displayed on CLCD. Heater and cooler will be used to increase or decrease the temperature simultaneously.
And the another component is LED. It is used for garden lights. So when we increase the intensity, the LED glows at a high intensity, and when we slow down the light of the intensity of the LED comes down. The other component we use is Ethernet. It is used to control the blink cap and to connect it with our project through internet. And the another component, so serial tank contains two valves. One calls inlet valve and the other is called outlet valve. So through inlet valve we can fill the water in the tank, and through the outlet valve we can draw the water from the tank. It is controlled by our mobile app known as Lamp IT.
In this project, we have some requirements. Number one requirement is control of garden lights. We have to read the LDR sensor value, based on which reading from LDR, LED will glow or it will dim. If we increase the intensity of LDR, LED will go dim, and if we decrease the intensity of LDR, the LED will glow, which resembles the controlling garden lights based on availability of sunlight.
Next peripheral is temperature control system. So the temperature control system consists of heater resistor and an LM35 temperature sensor and a cooler. Read the temperature from the temperature sensor and display it on the CLCD. Control the temperature of the system by turning on and off the heater and cooler through the Blink IoT app. Water tank and inlet outlet wave control. Read the volume of the water in the tank through the serial communication and display it on the CLCD. Control the volume of water in the tank by controlling the inlet and the outlet valve by sending commands through the serial communication. The display the volume of the tank on the CLCD.
And last, we have to make a threshold control. Like in heater, if the temperature rises above 35 degrees Celsius, then the heater should turn off automatically. And if temperature temperature is more than 35 degrees Celsius, then we have to turn off the heater, and it should be displayed on the virtual terminal on the blink app. And in serial tank, if the inlet valve is full, then it should then it should turn off the inlet valve automatically and display water level is low, and water inflow will be disabled automatically. So this is our project integration, in which we are using LDR, CLCD, LED, Ethernet and temperature system, and it will be controlled by a Blink mobile app, just like a home automation. Now we will be moving ahead to display our project. As you all can see that this is my Pixim lab. I am going to connect the serial tank using the tools. Also, you can see that in my Pixim lab it has one start button where my pointer is now, and now it has a lot of pins. As you can see, different pins are connected to spare parts of Arduino Uno, using which we run our project. Now I am connecting. So my serial tank is connected now. This is my project interface. It has CLCD, internet and heater control, LED. Now I will start my serial tank, and you can see that water has been coming inside the serial tank, and at the same time you can see that it is displaying on the CLCD as well as in my Blink app. Now water is rising, and when it will full, the outlet will automatically off. Now since I off the outlet valve, it has since I on the outlet valve, the water is started decreasing. Next I will on the heater. So upon as you can see, the temperature is started rising, and as it crossed the 35 degrees Celsius, heater turns automatically off and temperature is decreasing slowly, and has been also displayed on my blink app. Now if I on the cooler, the temperature will decrease. So let me on the cooler. As you can see, that temperature has been decreasing and my cooler is also on. Next you will see that if in my LDR the intensity of high, so there no LED is glowing. But if I decrease the intensity uh, uh, by increasing the resistance, so as we increase the resistance, the intensity of LDR will decrease and my LED will glow just like the garden lights. And you can see that my LED is glowing and it's connected to pin number 3. So this is all my project. uh, Moving ahead to conclusion. So in conclusion we can say that uh, using the Blink IoT application and Pixim Lab simulator, we have simulated an home automation in which an LED, a temperature system, a serial tank resembles like a light, heater and cooler and water tank in real time. So using our Blink IoT app, we can control our heater, cooler and water tank, and using LDR we can control our garden lights. So this is all my project, and I would like to thanks Jay Lakshmi ma'am for guiding us this complete 1 month. It has been a wonderful experience to learn from her, and I would also like to thanks Emertxe for this wonderful opportunity to present my skills. Thank you.